And we're back and ready to now titrate our Green River samples. And so with these samples, they've already been prepared with all the solutions. They've been prepared with the potassium iodate, with the iodine. Everything's ready to go. And so our solutions are actually starting out already with our nice yellow color. And so we can just start titrating. And so this is Green River sample spot 1. My initial volume is at 0.20 milliliters. And so I'm just going to, same exact idea with all of these, titrate until a pale yellow, and it's happening pretty quickly with this one. Add in my starch. Blue is starting to go away, so I'm going to start more slowly. And it's gone. Final volume. .65 milliliters. So now I'm just going to go through the rest of them, and I'm going to do probably 4 of each of these, just so we make sure that we have 3 really good trials. You can see they go pretty quickly once we get into a groove. And I'm probably going to do less commentating now, just so that I can zip through the titrations. Final volume for the second trial, 19.30 milliliters. Final volume for the third trial, 28.85 milliliters. Final volume for our fourth trial, 38.15 milliliters. And so that was for Green River sample spot 1. Now we'll have to get ready to do Green River sample spot 2. I'm going to use these same flasks. Just rinse these out. Actually, I tell you what, I'll do you a favor. All the rest of the titrations are going to be performed in the same way. I am going to do them, but you don't have to necessarily watch me do them. They will all be performed exactly as I just did here. And so you can record that in your notebook, that all of the other sample spots were titrated in this, using the same exact method. And the data will be posted with the data for the rest of the lab. One thing to note as well, another titration that I will be performing is for a 4.0 ppm standard. Now, one of the issues with a lab like this, where we're measuring dissolved oxygen, is that oxygen is present in our atmosphere here. Oxygen is present in the air. And so even as careful as our lab associate Lee is, who does all of the prep for us, she does a fantastic job for us, as careful as she is with the preparation and doing things like, you can see in this bottle, leaving virtually no headspace in here for oxygen to interact. The bottom line is that even through working with these samples, through me pouring these into the graduated cylinder, which I did before I started the video for sample spot 1. I poured 30 milliliters of this into the graduated cylinder, poured that into the Erlenmeyer flasks. Even that process is introducing oxygen onto the samples, some of which will diffuse into the samples. And so the reason we do the 4 ppm standard is because we know that that one was prepared to have 4 ppm dissolved oxygen level. And so what we can do then is measure the dissolved oxygen of that 4 ppm standard and use that as our baseline to determine how much oxygen the samples are picking up just through our process. And so you can then make adjustments to your final dissolved oxygen levels by using that. Let's say, just as a for instance, because I haven't run that yet, I will after I stop the video, but let's say for instance that we find the actual concentration in this standard to be 4.7 ppm. That means that our process is reliably adding 0.7 ppm to the actual dissolved oxygen level. And so you would adjust your dissolved oxygens of your samples by that amount. And so let's say you found again, just to throw a number out there, let's say you found the dissolved oxygen of sample spot 2 to be 12 ppm. It's definitely not, but just to throw that number out there, let's say you found sample spot 2 to be 12 ppm, but our 4 ppm standard is measuring at 4.7, you're going to subtract that 0.7 from the 12, which would mean that sample spot 2 would really be 11.3 ppm, and you would record and reflect that in your data. And so I will also have data on the website for that 4 ppm standard for you to use. And so that is all for the video. I'm going to go ahead and complete the rest of the titrations after I take a quick break for myself. And like I said, you can record in your notebook that all of the titrations were performed using the exact same method. And this has been the Winkler method of finding the dissolved oxygen content. Everyone have a great day.